To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. Today I am going to discuss with you all questions related to electronics. So I am going to start with the questions given in your textbook. I am sure you all would have already answered the questions. If not, answer them by yourself first and then compare your answers with my discussion. So in the lesson, we started off the lesson by discussing what semiconductors are and how they act as intrinsic semiconductors, where the bonds in the lattices, that is the bonds between, let's say silicon lattice, the bonds between silicon atoms in the lattice is broken due to temperature. When the temperature is more than 0 kelvins. Then because of that, there will be a few free electrons and holes. Holes is the absence of electrons. So in semiconductors, both negatively charged electrons and positively charged holes act as charge carriers. So because of that, they can conduct electricity. But that is not sufficient. Therefore, these semiconductors are doped with either group 3 or group 5 elements to produce the P-type and N-type semiconductors respectively. Then, when a silicon semiconductor is doped with both group 3 and group 5, we get the PN junction. And at the junction, there is a depletion layer that acts as the potential barrier. And by forward biasing the PN junction, we can overcome that potential barrier. So when forward biased, the PN junction will allow the current to flow in one direction. Because of that, diodes or PN junction diodes have many uses. For example, we discussed the half-wave rectification, full-wave rectification of current, where we convert alternating current to direct current. And then to protect electrical appliances from incorrectly connected terminals due to electricity supplied through incorrectly connected terminals. And then you were able to understand what LEDs, light emitting diodes, and solar cells are. Thereafter, we saw devices with two PN junctions, that is the transistor. And under that, we discussed the two types of transistors, NPN and PNP transistors. And you were able to understand how they also can be forward biased. Thereafter, we discussed the functions of transistor. Function of transistor as a current amplifier, signal amplifier, a switch, and also how it can be used as an automatic switch. So they were the functions of a transistor. I am sure you all have a good understanding of the lesson. So now we will discuss the questions related to the lesson. Exercise. The first question, first part, explain briefly how metals and semiconductors conduct electricity. Now for any material to conduct electricity, there should be free charges or mobile charges. If you take the metals based on the metallic structure, that is the metallic lattice, there are free electrons. So the free electrons that can move conduct electricity. And if we take the semiconductors, like I said, when the semiconductor lattices, some of the bonds are broken, there will be free electrons and holes. Based on that, they conduct electricity. So that is what you need to write here. Explain briefly how metals and semiconductors conduct electricity. So here we can say there are free electrons in metals that conduct electricity. In semiconductors, at temperature greater than 0 Kelvin, there will be some free electrons and holes that contribute to conducting electricity. So you all know, students, in metals, normally in the metallic structure, that is the metallic lattice structure, you all know the loosely bounded electrons, that are the electrons from the valence shell, they tend to come out of the atom. So because of that, there are many free electrons and they can move randomly, but when a potential difference is supplied, then of course the electrons start moving in one particular direction. Because of that, they can conduct electricity well. But in a semiconductor, only when the temperature is greater than 0 Kelvin. At 0 Kelvin, you all know, all the electrons are bonded. All the atoms are bonded together. Because of that, there are no free electrons. All the electrons are part of the bonds. But when it is more than 0 Kelvin, due to that temperature, what happens is some of the bonds are broken, and because of that, there will be a few free electrons, and where the electron occupied earlier becomes a space. That becomes the holes. Holes are similar to positive charges, and both holes and electrons conduct electricity. So usually it is an intrinsic semiconductor. It is called an intrinsic semiconductor. In an intrinsic semiconductor, there are equal number of holes and electrons. So therefore, they are electrically neutral, but still they can conduct electricity. So that is how they conduct electricity. Then, the second part, how does the increase of temperature affect the conduction of electricity? Now you all know, temperature increases conductivity in different ways. If we take the metals, now in metals, when the temperature increases, the random movement of electrons increases. Why? Because you all know, normally thermal energy gives rise to kinetic energy. So kinetic energy of electrons increases. Because of that, their random motion increases. So then the resistance of the conductor increases with increase in temperature. Because of that, the conductivity decreases. That is in metals. So in metals, the conductivity decreases with increase in temperature. What happens in a semiconductor? When the temperature increases, there is more heat energy provided to the semiconductor lattice. So because of that, there will be more bonds broken. Therefore, the number of free electrons and number of holes will increase. Because of that, the conducting ability or conductivity of semiconductors will increase with temperature. So, temperature affects the conductivity in two different ways to the conductor or the metal and the semiconductor. You have to understand that. So, if we write the answer there, can say metals, when temperature increases, the random motion of electrons increases. Then or therefore the resistance increases and the conductivity decreases. So that is ability of metals to conduct electricity decreases with increase in temperature. But in semiconductors, what happens? When the temperature increases, there are more covalent bonds broken between semiconductor atoms. So because of this, there will be more number of free electrons and holes generated. This will increase the conductivity of the semiconductor. So therefore, conductivity of semiconductors increases with increase in temperature. So conductivity of metals decreases with increase in temperature. Conductivity of semiconductors increases with increase in temperature. So that is the explanation. I have given it separately for both. In metals, when temperature increases, the random motion of electrons increases. Therefore, the resistance increases and the conductivity decreases. That is, ability of metals to conduct electricity decreases with increase in temperature. So, then here you can see, so semiconductors, when the temperature increases, there are more covalent bonds broken between semiconductor atoms. Because of this, there will be more number of free electrons and holes generated. This will increase the conductivity of the semiconductor. So, therefore, conductivity of semiconductors increases with increase in temperature. So, this is the full explanation, students. why and how temperature affects the conductivity of both metals and semiconductors. But if you look at the question here, you can see how does the increase of temperature affects the conduction of electricity. There, of course, you can simply write a short answer as well. You can say when temperature increases, conductivity of metals decreases, and when temperature increases, conductivity of semiconductors increases. That is also enough. But here I have given you all a complete answer with the explanation. I'm sure you all can understand that. So then we'll move on to the next question. Second question, first one. A LED is not lighted up by one dry cell, but it is lighted when two dry cells are used. Explain why. So when we say LED, you all are familiar with LED, students. There are different colors. And you all know the minimum biasing voltage of an LED is 1.8 volts. But dry cell is 1.5 volts. So 1.5 volt is not enough to overcome the minimum biasing voltage of 1.8 volt. But when you use two dry cells, there is a voltage of 3 volts supply. So that is more than enough to light the LED. So that is the explanation you have to give here. So we can say minimum biasing voltage of LED is 1.8 volts. So, two dry cells, that is 1.5 into 2, 3 volt is required to overcome the potential barrier. Thus, one dry cell is not enough. Two dry cells are needed to light up the LED. So that is very important. You have to say minimum biasing voltage of LED is 1.8. Now you all know some are 1.8, then 2, 2.5, 5 volts. Like that, it's higher value. Minimum is 1.8. So even to light that up, you need 2 dry cells. So if it is a 5 volt LED, then of course you have to go for a 6 volt battery. 4 dry cells or 6 volt battery or even a 9 volt battery is needed. So you have to consider it accordingly. But here this is a general question where they have said one dry cell is not enough but 2 are used. So there you all should know that the minimum voltage is 1.8 volts. So when you use 2, that is 3 volt, that is enough to overcome the biasing voltage. I'm sure you all can understand that. So then, give examples for 3 instances where we use LEDs in day-to-day life. So 3 instances. Can you all think of the uses of LED? Now we use LED to light up the houses. LED bulbs, you all know they are very efficient. Then there are LED torches, LED headlights of vehicles. So basically for lighting. Then LED TV screens, television screens, which are also energy efficient and more usable. So there you all know the efficiency of the LED screen is more. At the same time, the space consumption is also less. There are very thin LED screens. So that is another application. And also we can use them as indicators. in maps and other different places where we use them as indicators. Actually, in the early days, LEDs were used as indicators mostly. But now only they are being used to make LED televisions as well as LED lights. So we can write all three uses here. And here also you can write them separately. LED bulbs, LED torches, LED headlights, but all of them come under lighting. So because of that, what I will do is I will write that as one use. So here we can say LED is used for lighting purposes. Lighting purpose. If you want, in brackets we can say headlights of vehicles, then torches, and also we can say household lights. Household LED light bulbs. Then the second application, LED television. And then as indicators. So here you can write it generally as LED is used for lighting purpose, or you can give one of these examples, headlights of vehicles or torches, LED torches or LED light bulbs in the household circuit. Then LED television and as indicators. Those are uses of LEDs in day-to-day life. So with that, I will move on to the next slide. But here again, you have to remember, students, when we say uses in day-to-day life, we can also consider the rectification process. Because like in devices like laptops, mobile phones, we have the power packs, the chargers. In those, there is the rectification circuit. So there we use LEDs. So that is also an application of LED. I have mentioned that to you all before when we discussed the half-wave, full-wave rectification. These rectifier circuits are available in power packs, which are used with laptops and mobile phones and televisions, most of the electrical and electronic appliances. So you can include that also. So those are the uses of LEDs in day-to-day life. With that, students, we will move on to the next slide. The use of LEDs which give white light instead of filament bulbs is increasing now. Give reason for this. Now you all know, students, normally a filament bulb, the power consumption, electricity power consumption is about 60 watts. Whereas an LED bulb, the power consumption is about 6 to 8 watts. And also the lifetime of LED bulbs is about 50,000 hours. So it is a long lifetime. Because of that, although the initial cost is high, in the long run, using LED light bulbs is very, very efficient. Energy efficient as well as cost efficient in the long run. So because of that, the use of LED instead of filament bulbs is becoming more and more in the current days. So that is what you have to write here. So here we can say, compared to filament bulbs, the energy consumption of LEDs is very less. So I'll say 6 to 8 watts. And the lifetime of LEDs is very high. That is about 50,000 hours. So, compared to filament bulbs, the energy consumption of LEDs is very less, that is about 6 to 8 watts, and the lifetime of LEDs is very high, that is 50,000 hours. So, therefore, the use of LED instead of filament bulbs is increasing now. So, we can complete the answer with that. Therefore, the use of LEDs which give white light instead of filament bulbs is increasing. So, that is just to complete the sentence. Otherwise, if you give up to here, it is more than enough. Compared to filament bulbs, the energy consumption of LEDs is very less, that is 6 to 8 watts, and the lifetime of LEDs is very high, that is 50,000 hours. Therefore, the use of LEDs which give white light instead of filament bulbs is increasing. I am sure you all also have written a similar answer. So, with that students, I will move on to the next question. So, here we have question number 3. It has been stated in the activity 11.6 that a transistor can be used as a switch to light a bulb in the dark. So, here it should be bulb in the dark, light a bulb in the dark. There is a printing mistake in the textbook. A student plans to modify the above circuit to open the garage door automatically when the headlights of a car falls on it. So, a student wants to modify circuit to open the garage door automatically when headlights of a car falls on it. So, if you look at this circuit students, the circuit that is given to you is the circuit for the activity 11.6. You can remember that where we use the transistor as an automatic switch to turn on the lights in the dark. When night falls, automatically to turn on the lights. So, for that you can remember the circuit here. We have the NPN transistor. You can identify the symbol there, D400 or D313. And here you can see between the base and the emitter, we have an LDR, a light dependent resistor. So, that acts as the light sensor. You can remember that. Now, light dependent resistor, when there is no light incident on it, that is if it is dark outside and no light is falling on the LDR, the resistance is high. So, then it will not allow current to flow through that. But when there is light incident on the LDR, when there is light falling on the LDR, depending on the intensity of the light, the resistance of the LDR decreases. So, then it will allow current to flow through it. So, then here you can see we have the 3-volt battery there and a light bulb here connected to the collector terminal, and here we have a volume control resistor. So, volume control resistor to control the current flowing through the circuit and LDR acting as the light sensor. Now, you can remember this activity students. Now, I am explaining the activity that we did before where we use transistor to turn on the light during darkness. So, what happens there? During the daytime when there is enough light, what will happen? The resistance of LDR will be less. So, because of that, when current flows this way, it flows through this circuit, through this external circuit, through the volume control resistor. We use the volume controller, we adjust it so that the bulb lights up a little bit. So, you all know that. So, then current flows this way. Now, since the resistance of LDR is very less, current does not go into the transistor. Instead, current flows this way. So, it flows through the external circuit. Daytime when there is light. So, then the transistor acts as an open switch. Why? There is no current flowing through the transistor. So, this bulb will not light. Daytime when there is light. So, their transistor is going to be open switch. Transistor open switch. And this bulb does not light. Does not light. You can remember that. Here daytime light on LDR. What I meant as light is light on LDR. The other instance, if I use a different color, you can remember night time or when there is no light falling on the LDR. Intensity of light falling on the LDR is less. Then what will happen? The resistance will be high. So, night time, no light on LDR. Then what will happen? Now again current is flowing this way here, and when it comes to this point, now the resistance of LDR is very high. Why? It is dark. There is no light falling on the LDR. So, because of that, current cannot flow this way. Instead, current flows into the base. So, when there is current flowing into the base, what will happen to the collector current? There will be current flowing through the collector as well. You all know, always there should be an input current. The base current has to flow so that the output current will flow. Since it is an NPN transistor, it's going to be the collector current. So, because the resistance of LDR is high, current flows through this, and because of that, there will be a collector current also flowing this way. So, because of that, this will light. The bulb will light. You can remember that. The bulb will light. Bulb will light. So, here, night time, no light on LDR, resistance high, current flows through the transistor. So, it becomes the closed switch and the bulb lights. So, that is what happens in this particular activity. I am sure you all can understand that. So, this is the activity that we did before. So, just to make sure, this is activity. The number is 11.6. What is mentioned in the question. But now we need to modify this. How do we modify this? Now here, to write the modified answer, I'll use a different color just to separate this so that you don't get confused. Right. So, this is the activity that we have discussed. Now, if we look at the question, you can see, design a circuit for building a small model of the system for the school exhibition. Draw the circuit and name all the components. The student hopes to use a 3-volt motor to open the door. So, the student hopes to use a 3-volt motor to open the door. And the door should open when the headlight falls on the sensor. So, when the car is near the door, the headlights fall on the sensor should detect it, so it has to be a light sensor, and then the transistor should become a closed switch. It functions and allows electricity to flow through it. Therefore, it will open the garage door. So, we have to modify that. So, how do we do that? That is what we need to explain here. So, here it is going to be the modified circuit. Modified circuit to open the garage door when light falls on the sensor. So, here also we need a light sensor. What can we use as the light sensor? You can remember the LDR is usually a light sensor. So, LDR is the light sensor. But can we use the same circuit? No. Why? Because in this circuit, during night time only the bulb lights. But here we want the motor to function when light falls on the circuit. So, to do that, we need to change the position of the LDR. So, what I will do is, I will first draw the circuit, the modified circuit, and then I will explain it to you all. So, if we do that, I am going to draw the modified circuit here. So, we need to have the transistor there. The same. Then we have the circuit with the batteries. This part will not change. We will have the same batteries. So, here it's going to be 3 volt potential positive. That is fine. Then what we need to do is, instead of having the light bulb there, we will need to have the motor there. 3 volt motor there. So, we will have the 3 volt motor there. Why? We don't need the light to come on, we need the motor to function. Now, this is the part where we need to modify. So, we will have the volume controller there. So, then we need to show the, so this is the volume controller VR. So, we have changed it. We had the LDR here, we have brought the volume controller here, and I will put the LDR there. LDR will go here. So, this is going to be the LDR. Is that clear, students? So, we have the LDR here and the volume control resistor here, the transistor, NPN transistor there. Now, what do you think will happen? Now, when light falls on the LDR, the resistance will be less. So, resistance will be less. Then, there will be current flowing this way, through the LDR, and when it comes to this point, there will be current flowing through the base of the transistor. So, when there is base current flowing, obviously there will be a collector current flowing. From this way, the collector current also will flow. So, because of that, the 3 volt motor will function. But here there is something that we need to consider, students. We have the LDR, we have the transistor and a 3 volt motor. Then of course, instead of having 3 volts here, we will have to have more than 3 volts. So then I will change that as well. Instead of having 3 volts, I will say greater than 3 volt. Earlier we needed 3 volt batteries. Now we have an additional 3 volt motor. So we will have to go for at least a 6 volt battery or maybe even a 9 volt battery. So here greater than 3 volt. So what happens? So light falls on it. The resistance of LDR is less. So because of that, the current flows this way, comes through the LDR and flows into the transistor. So if a base current flows, automatically a collector current also will flow and the motor will work. But when there is no vehicle, when there is no headlight, then what will happen? It will be dark here. So the resistance of LDR will be high. Then the resistance of this particular path will be high. So what will happen? There will be no current flowing this way and there will be no current flowing through the transistor. Because of that, if there is no base current, there will be no collector current. Then of course the motor will not work. Is that clear? So by changing the positions of the LDR and the variable resistor as well as fixing a motor here, and in addition to that we need to increase the supplied voltage as well. So there what will happen? When there is no light, the resistance of LDR will be high. Because of that, current cannot flow through this circuit. Accordingly, we have to adjust the volume controller also. But when there is light falling on the LDR, the resistance will decrease. Because of that, current will flow from the battery to the base of the transistor. Because of that, there will be a collector current flowing. And that will make the 3 volt motor to function, which will automatically open the garage door. Is that clear, students? So that is what we need to write here. So here we can say the circuit is modified as shown above. We will label the shown above. So you all know this is the modified circuit. So when there is no light falling on the LDR, the resistance is high, therefore there will be no current flowing through the circuit. The transistor acts as an open switch. When the light is incident from the headlights. I'll put this in brackets. When the light is incident on the LDR. Because here when we make the model, we are not going to use a car headlight. We will be shining a torch, or in some way we will be providing light. Either you can close the LDR with a cloth and open it to let the light to fall on it, or somehow we will allow the light to fall on the LDR. That is why I have written this in brackets. So when the light is incident on the LDR, the resistance decreases, then current will flow through the base and collector. Therefore, the transistor acts as a closed switch. The collector current that is IC flows through the motor. 3-volt motor, and it functions. So here it will open the garage door. So that is what happens. And here, as a note, motor requires 3-volt potential. In addition, there is the volume control and the transistor. Therefore, at least 6-volt potential should be supplied by the batteries. So that is something we need to consider, students. Accordingly, depending on the power of the motor, we need to supply potential. So here, if we go back and look at this. So this is something I already explained to you all. This is the activity where we use it as an automatic switch. But here you have to remember, light comes on when there is dark outside. When there is no light falling on the LDR, transistor is a closed switch and the bulb lights. When there is light falling on the LDR, transistor becomes an open switch and the bulb does not light. That is the activity. But here we have modified it to suit our requirement. Modify circuit to open the garage door when light falls on the sensor. And LDR is the light sensor. We have modified it. How? You have to remember, now this part, you have to remember, this has to be changed because the motor itself is 3 volt. So it has to be more than 3 volt, maybe 6 volts. So I will just mention it as 6 volts. Then we have changed the positions of the LDR and the volume control resistor. We need the volume control resistor for a voltage drop there. At the same time, we have the LDR here. So, when there is no light falling on the LDR, the resistance is very high. So, because of that, there will be no current flowing through the circuit. But when light falls on the LDR, what will happen? The current will flow. How does the current flow? From here, the current flows this way through the LDR to the base of the transistor. So, that will be the IB current, base current. Because of that, there will be current flowing through the collector, that is the IC current. The IC current flows through the motor. And that current will make the motor to function and open the garage door. That is how the circuit is modified. I am sure you all can understand that. So, this is the explanation here. The circuit is modified as shown above. When there is no light falling on the LDR, the resistance is high. Therefore, so here you can see, therefore, there will be no current flowing through the circuit. The transistor acts as an open switch. Then, when the light is incident, that is from the headlights on the LDR, the resistance decreases. Then current will flow through the base and collector. Therefore, the transistor acts as a closed switch. The collector current, that is IC, flows through the 3-volt motor and it functions, that is to open the garage door. But here I have given this as a note. Motor requires 3-volt potential. In addition, there is the volume controller and the transistor. We adjust the volume controller so that when the transistor is not functioning, there is no current flow through the external circuit also. So, because of that, here again, therefore, at least 6-volt potential should be supplied by the batteries, because in the previous circuit also we had 3-volt potential. Now there is an additional 3-volt motor. So at least a 6-volt potential needs to be supplied. I am sure you all can understand that, student. So that is how the student will modify the circuit. Is that clear? So then with that I will move on to the next slide. Question number 4. The following figure shows a circuit made to study about the rectifier bridge in a school exhibition. All the diodes needed in the circuit are 1.8 volt LEDs. So here you can see the circuit, students. You all are familiar with this. Now what they have said is all these diodes, D1, D2, D3, D4, D5, D6, there are 6 diodes and all of them need 1.8 volts biasing voltage. So, for one diode, we need to provide 1.8 volt LED. So, there will be a voltage drop of 1.8 volts for one particular diode. So, now if you look at the circuit, here you can see the dry cell 6 volt potential is provided there. 6 volt potential and the positive terminal and the negative terminals. So, you can see the current will flow from the positive terminal to Y and then to this point. Thereafter, you can see the connection of the 4 diodes, that is the rectification bridge circuit. You can remember that. We have done the activity. This is for the full wave rectification when we use 4 diodes. So, then you all know when current flows through Y, D4 is reverse biased, D5 is forward biased. So, current will flow through this, then through this point, then again here. Now, in the activity you can remember, we use either a galvanometer or we have discussed with one diode. But here you can see there are 2 LEDs connected in the opposite direction. Now, when the current flows in this direction, which diode will be forward biased? Now, here you can see D2 current flows this way. So, that is forward biased. But D3 you can see the current flow direction is that way. So, this is reverse biased. So here we saw through D5 current will flow, then through D2 current will flow, then it will flow back up to this point. As it reaches here, you can see D4 is there, but current cannot flow through that because again it's connected to point Y. So because of that, D4 also is reverse biased for this particular instance. Then current can flow through D6 this way and to point X. So that is how the current will flow. So you can see here Y, D5, then D2 and D6. Those are all forward biased. D1, D4 and D3 are reverse biased. You all know the function of a rectifier bridge. So there will be 3 diodes that need to, that is 3 LEDs that need to be function. So each LED 1.8 volts. So for 3 LEDs, you need to supply 3 times 1.8 volts. So that is going to be 5.4 volt voltage drop will occur across the LEDs. So that is why you can see here a 6 volt battery or 6 volt potential difference is supplied. Is that clear, students? So you will observe the full wave rectification, or you will see that the diodes D5, D6 and D2 will light, whereas D1, D3 and D4 will not light up. Is that clear to you all, students? So this is the same activity where we try to understand the full wave rectification, but here you have to understand the position of the LEDs. So although the numbering is different, now earlier we only use 4 diodes, but here there are 6 LEDs. So depending on the position, you need to identify which is forward biased and which is reverse biased. Is that clear? So then, the first one, which LEDs are lighted up when a 6 volt battery is connected to the terminal X and Y? So I have already explained that. Which LEDs are lighted up? What are lighted up? You can see D2, D5 and D6. So the answer is going to be D2, D5 and D6. You can write it in any order, no problem. But you have to write all 3 LEDs. D2, D5 and D6. Like I showed you all, current flows from the positive terminal to Y, then to this point, then D5, D2 and D6 back to point X and back to the dry cell. Is that clear? So 3 diodes are forward biased. Then we'll move on to the next part of the question. So here you can see second part, mark the direction of the current drawing arrows near the LEDs. So we need to mark the direction of the current. So here, like I said, current flows through Y, current flows through D5. Then at this point, current flows from this here and then through D2, then here and then D6. Back to X. So you have to show these arrows, D5, then D2 and D6. That is very important because they have said drawing arrows near the LEDs. So that is important. D5, then D2 and D6. Is that clear, students? So we have answered this question. Mark the direction of current drawing arrows near the LEDs. Then the next part, third part of the question. What will happen if the battery is connected to X and Y in the opposite direction? What will happen then? Instead of this connection, if we had the positive terminal near X and negative terminal near Y. So what I will do is I will erase this and there I will show you all how we can change the bulbs. So here, this is going to be the positive terminal, that is going to be the negative terminal, and here again we are going to supply 6 volt battery. So that is how the change is going to take place. What will happen if the battery is connected to X and Y in the opposite direction. So now what will happen? You can see current will flow through X. It will come to this point. Here you have D1 and D6. D1 is going to be forward biased. Then at this point, D5 is reverse biased. Here already D6 is reverse biased. So current flows this way to this point and again through D2. D2 is forward biased. But D3 you can see is reverse biased. So current again flows this way to this point and here it is going to be D4 that is forward biased. D6 will be reverse biased. So current flows back to the point through Y. So the direction is going to be X, D1, D2, D4, Y and the battery. So here in this instance, you will see that D1, D2 and D4 will light up, whereas D3, D5 and D6 will not light. That is what will happen. So what will happen if the battery is connected to X and Y in the opposite direction? You can say diodes. You can see D1, D2 and D4 will light. If you want, you can say D3, D5 and D6 are reverse biased. Or we can say will not light. But in both instances, you can see students, D2 lights up. So that you can remember when we had the galvanometer or any other device there, always the current flow through that point. Here, this is the output. Current flow through this output is going to be in the same direction. That is how the alternating current gets rectified into direct current. So always these change. Now it is D1 and D4. Earlier it was D5 and D6. But out of these two, D2 and D3, it is always D2 that is forward bias. So the direction of the current flow is this way, through D2, not D3. I'm sure you all can remember that. So then, here you can see we have answered the question. D1, D2 and D4 are forward biased or they will light up. Others, D3, D5 and D6, they are reverse biased, therefore they will not light. Then the fourth part. What would happen if a 3-volt battery is used to supply current instead of a 6-volt battery? Give reasons for the above. Now, if we use a 3-volt battery, the circuit will not work. Why? I have already told you all the reason. Now, in both instances, there are 3 LEDs that need to light up. So, for one LED, the biasing voltage is 1.8 volts. For 3 LEDs, we need 1.8 into 3, 5.4 volts. So, because of that, 3-volt battery is not enough for the circuit to function. So, here, what would happen if a 3-volt battery is used to supply current instead of a 6-volt battery? So, there the answer is the circuit will not function. That is the LEDs will not light up. Why? Because the biasing voltage of one LED is 1.8 volts. In both instances, there are 3 forward biased LEDs. Thus, the voltage drop equals 1.8 volt into 3, that is 5.4 volts. This cannot be provided by a 3 volt battery. Therefore, a 6 volt battery is needed. So that is what the explanation is. The circuit will not function, that is the LEDs will not light up. Why? Because the biasing voltage of one LED is 1.8 volt. In both instances, there are 3 forward biased LEDs. Thus, the voltage drop is equal to 1.8 into 3, that is 5.4 volts. This cannot be provided by a 3 volt battery. Therefore, a 6 volt battery is needed. Is that clear? So, that is the answer to this question. So, with that, students, I have completed the questions given in your textbook. So, I am going to end this chapter, and in the next chapter, I will discuss some extra questions with you all.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.